Sixth grade, Module 4, Lesson 20, Classwork. Example 1. The farmer's market is selling bags of apples. In every bag, there are 3 apples. Complete the table. So, in one bag, there would be 3 apples. So every bag, there's 3 apples. That means in 2 bags, there'd be 3 in each, which would be 3 plus 3, or 6. In 3 bags, 3 plus 3 plus 3, or 3 times 3, would be 9. 4 bags would have 3 more apples, so that would be 12. What about B bags? What we were doing each time was multiplying by 3. So we could do 3 times B, or just leave it as 3B. So B bags would have 3 times B number of apples. What if the market had 25 bags of apples to sell? How many apples in that? So if B is equal to 25 apples, then we would just need to do 3B, or 3 times 25, which would be equal to 75 apples. There would be 75 apples in 25 bags. C, if a truck arrived that had some number, A, more apples on it, then how many bags would the clerk use to bag up the apples? So if we knew the number of apples, so for example, maybe we know that there's 30 apples, how would we get to this? What we would do, instead of multiplying by 3, to go backwards, we would divide by 3 to figure out the number of bags. So we would do A, the number of apples, divided by 3 would give us the bags. And yep, I think that answers all parts of that. So D, if a truck arrived that had 600 apples, so now we have 600 apples. 600 apples. How many bags would the clerks need to use? So 600 apples, we can put 3 in each bag. So divided by 3, 600 divided by 3 would be 200 bags of apples. And how is part D different from part B? So part B here, they gave us the number of bags. In part D, they gave us the apples. So let's say part B, we are given the number of bags and need to multiply by 3 to find the apples. In part D, we are given the number of apples and must divide by 3 to find the number of bags. Number 1, in New York State, there is a 5-cent deposit on all carbonated beverage cans and bottles. When you return the empty can or bottle, you get the 5 cents back. Complete the table. So if you return 1 can or 1 bottle, what is your refund in dollars? Notice it says in dollars. So we're going to need to convert the 5 cents because it tells us you get 5 cents back, but we don't just want to put down 5. We need to put it down in dollars. So 5 cents would be equal to 5/100ths of a dollar. So we're going to write 5/100ths. If we return 2 cans, that would be 5 cents times 2, which would be 10 cents. And we can just keep adding 5/100ths until once we get to 4, the next one is 10. So we need to multiply that by 5/100ths, which would give us 50 cents. If we multiply 50 times 5/100ths, we would get, 50 times 5 is 25. So we just need to move the decimal 2 places, so that'd be 2 and 50 hundredths, $2.50. 100 times 5/100 would be $5. And C, we just know we need to multiply it by 5/100. So we get 5/100 times C, just like what we've been doing for all of the other number of containers. If we let C represent the number of cans, what's the expression that shows how much money is returned? We already did that for the last one, so it would be 5/100 times C. Use the expression to find out how much money Brett would receive if he returned 222 cans. So he returns 222 cans. We need to multiply it by 5/100. And so all we'd have to do, let's do 222 times 5/100. 5 times 2 is 10, plus 1 is 11. 5 times 2 is 10, plus 1 is 11. And then we just need to move the decimal point 2 places, since there are 2 digits behind a decimal point in the problem. So we get $11.10 is how much he would have returned for 222 cans. If Gavin needs to earn $4.50 for returning cans, how many cans does he need to collect and return? So now it's going the opposite way. So instead of multiplying by 5/100, we need to divide by 5/100 because we know the amount of money, but not the number of cans. So let's do 450 divided by 5/100. So what I'm going to do is move the decimal point 2 places just to get rid of it. So now it's just 450 divided by 5. So 5 can't go into 4, it can go into 45 9 times. That is 45. Bring down the 0. 5 can't go into 0. I'm going to put a 0 up there. There's nothing to bring down, no remainder. So our answer would be 90 cans. Because we did 450 divided by 5/100. How is part D different from part C? So in part C, we needed to multiply. Part C, we knew the number of cans and could multiply by 5/100 to find the amount of money he would receive. In part D, we knew the money he needed. And had to divide by 5/100 to find out how many cans he would need. Number 2, the fare for a subway or local bus ride is $2.50. Complete the table. So one ride would be $2.50. 2 rides, so if we did it twice, would be times 250, would be $5. 3 times 250 would be $7.50. 4 times would be $10. 5 times would be $12.50. 10 times, so times 250 would be $25. 30 times 250, See, it's getting a little bit bigger, but I know 10 times is $25, so I could just multiply that by 3 and get $75. And then R times, we'd have to do 250R. So 250 times R. Or if you want to simplify it, you could just leave it 2 5/10 R. If we let R represent the number of rides, what is the expression that shows the cost of rides? So just what we'd written before, 2.5 times R, 2 5/10 times R. Use the expression to find out how much money 60 rides would cost. So 60 rides, we need to multiply that by 2 5/10. So we can either multiply it out, or you can use other strategies. I'll multiply it and then I'll tell you another strategy. So 0 times 5 is 0, 0 times 2 is 0, put my 0 down. 6 times 5 is 30, carry the 3. 6 times 2 is 12, plus 3 is 15. Add it together. Now there was one digit behind a decimal point right there, the 5, which means we need to move the decimal point over one place. So we get $150 for 60 rides. Another way I would have done it is split this up and done, I know 60 times 2 is 120. 60 times a half, or half of 60 is 30, so just do 120 plus 30. You can also just multiply it out. Erase that so that I can read the next question. If a commuter spends $175 on subway or bus rides, how many trips did the commuter take? So this time, they tell us how much they spent. So instead of 2.5 times R would equal the cost, we have the cost. So 2.5 times, we don't know how many rides, is equal to 175. So we need to work backwards and divide. So let's do 175 divided by 2 5/10. Move the decimal point over one place. That's going to add a 0 and then bring it straight up. So 25 can't go into 1 or 17, but it can go into 175 7 times, and that would be 175. Subtract, we get 0. Bring down the 0. 25 can't go into 0. No remainder, nothing to bring down. So we get 70. So that would be 70 trips. How is part D different from part C? So in part D, they told us the cost and wanted to know how many trips it would pay for. Whereas in part C, they gave us the number of trips and wanted to know how much it would cost. And a challenge problem. A pendulum swings through a certain number of cycles in a given time. Owen made a pendulum that swings 12 times every 15 seconds. Construct a table showing the number of cycles through which a pendulum swings. Include data for up to 1 minute. Show the last row for C cycles and write an expression for the time it takes for the pendulum to make C cycles. All right, so we know, let's do the number of cycles, and the other side could be the time in seconds. Okay, so for 12 swings, we know that it is 15 seconds. What it wants us to do is include data for up to 1 minute, so 60 seconds, and then it wants to know how long it would take for a pendulum to make C cycles. So there are some things that they want to fill in right there, and we can keep going from there. So if I doubled it, 30 swings, that would be, or 30 seconds, that would be 24 swings. I could add another one on. Let's add 15 more seconds. That would be 36 swings. So far I've just been adding 15, and then every time I add 15 seconds, that's plus 12 pendulum swings. So then for 60 seconds, this pendulum swings would be 48. Okay, so now we have to find some sort of relationship between these numbers, because it doesn't help. This isn't super helpful if we want to know C, because C could be anything. So we need a relationship between the cycles and the second. To find the number of cycles per second, what I want to do is narrow it down to what if it was just 1 second? So what if the time was just 1 second? Because if we know 1 second, we can figure out just about anything. So if it is 15 seconds, for every 15 seconds there are 12 cycles. If I wanted to know 1 second, I could just do 15 divided by 12, and that would tell me how many I get in 1 second. So I'm even going to reduce that further. You could if you want. If I wanted to know, so since this is the seconds, I could put the C, so if I wanted 15C divided by 12 cycles, that would tell us how much time has elapsed. So let's do 15C over 12. Now, if I wanted to know 16 cycles, so we can do 15 times C over 12 would be 15 times 16 over 12. Now you could do 15 times 16 and then divide it by 12, but I'm going to do some cancellation and make this a little bit easier to solve without big elaborate multiplication and division problems. So I noticed that 15 and 12 have a common factor of 3. So I'm going to do 15 divided by 3 and make this 5 times 16. And then 12 divided by 3 would be 4. So then I could go on and solve 5 times 16 divided by 4. But now I also see that 2 other factors have a common factor. 16 and 4 both have a factor of 4. So if I divide both of those by 4, this turns into 1, and this turns into 4. So now I just have 5 times 4 over 1. And none of these have any more common factors. So it's just 20 over 1, which is equal to 20. So the elapsed time would be 20 seconds. If you're more comfortable just multiplying it all out and then dividing, go ahead and do that. Write an expression for the number of cycles a pendulum swings in S seconds. Okay, so we need to kind of work backwards. So what we could do is do 12 over 15, because that would be the number of cycles per second, right? Cycles per second, 12 over 15, in S seconds. So cycles per second, and then multiply it by however many seconds you have. So you do 12 over 15 S. Or you can reduce it like we did back here, we know 12 and 15 have a common factor of 3, so we could just make it 4/5 s. D. In a different experiment, Owen and his pendulum team counted the cycles of a pendulum for 35 seconds. How many cycles did they count? So I'm going to take this expression and use it to do 4/5 times 35, which would be 4/5 times 35 over 1. And I'm going to 35 and 5 both have a common factor of 5. So I'm going to make that 1, make this 7. 4 times 7 is 28. 1 times 1 is 1, which is just 28. So we get 28 cycles. That is the last question in lesson 20.